Today we discuss about queues concept in Laravel. So we are having topics like introduction, creating jobs, job middleware, dispatching jobs, job batching, queuing closures, running the queue worker, supervisor configuration, dealing with failed jobs, cleaning jobs from queues, monitoring our queues, and testing job events. So these are all the main topics within queues concept in Laravel. And also subtopics are there like connections versus queues, driver nodes and prerequisites, generating job classes, class structure, unique jobs, encrypted jobs, rate limiting, preventing job overlaps, throttling exceptions, delayed dispatching, synchronous dispatching, jobs and database transactions, job chaining, customizing the queue and connection, specifying max job attempts or timeout values, error handling, defining batchable jobs, dispatching batches, chains and batches, adding jobs to batches, inspecting batches, cancelling batches, batch failures, pruning batches, storing batches in DynamoDB, the queue work command, queue priorities, queue workers and deployment, job expirations and timeouts, cleaning up after failed jobs, retrying failed jobs, ignoring missing models, pruning failed jobs, storing failed jobs in DynamoDB, disabling failed job storage, failed job events, faking a subset of jobs, testing job chains, testing job batches, testing job or queue interactions. So these are all the subtopics that are available in queues concept in Laravel. Let's see one by one the introduction part. So when we build our web application, we may have some tasks such as parsing and storing an uploaded CSV file that take too long to perform during a typical web request. So Laravel allows us to easily create queued jobs that may be processed in the background. So by moving time-intensive tasks to a queue, our application can respond to web requests with blazing speed and provide a better user experience to our customers. So Laravel provides queued jobs concept in order to handle such kind of big tasks. Laravel queues provide a unified queuing API across a variety of different queue backends such as Amazon SQS, Redis, or even a relational database. Laravel's queue configuration options are stored in our application's config/queue.php configuration file. In this file, we will find connection configurations for each of the queue drivers that are included with the framework, including the database, Amazon SQS, Redis, and Beanstalk drivers, as well as a synchronous driver that will execute jobs immediately. So for use during local development, a null queue driver is also included, which discards queued jobs. Laravel now offers Origin, a beautiful dashboard and configuration system for our Redis-powered queues. Connections versus queues. So before starting with Laravel queues, it is important to understand the distinction between connections and queues. In our config/queue.php configuration file, there is a connections configuration array. This option defines the connections to backend queue services such as Amazon SQS, Beanstalk or Redis. However, any given queue connection may have multiple queues which may be thought of as different stacks or piles of queued jobs. We may note that each connection configuration example in the queue configuration file contains a queue attribute. This is the default queue that jobs will be dispatched to when they are sent to a given connection. If you dispatch a job without explicitly defining which queue it should be dispatched to, the job will be placed on the queue that is defined in the queue attribute of connection configuration. So this job is sent to the default connections default queue, process port cache dispatch for example. So dispatch method we can use in order to dispatch a job. So in order to run a waker that gives them higher processing priority, we will be using PHP artisan queue work --q equal to high comma default. This is the command which are used to run the queues. Driver nodes and prerequisites. So let's see database driver. In order to use database queue driver, we will need a database table to hold the jobs. Typically, this is included in Laravel's default 0001 underscore 01 underscore 01 underscore 000002 underscore create underscore jobs underscore table.php. Database migration, however, if our application does not contain this migration, we may use the make q-table artisan command. So it will be like this: PHP artisan make q-table. This is the command we can use in order to create the jobs table, migration table. The artisan command will be like this: PHP artisan migrate. So after creating queue table, we have to run the PHP artisan migrate command. Now we see Redis driver. In order to use the Redis queue driver, we should configure a Redis database connection in our config/database.php configuration file. The serializer and compression Redis options are not supported by the Redis queue driver. Redis cluster. Now we see Redis cluster. So if our Redis queue connection uses a Redis cluster, our queue names must contain a key hashtag. This is required in order to ensure all of the Redis keys for a given queue are placed into the same hash slot. Blocking. When using the Redis queue, we may use block for configuration option to specify how long the driver should wait for a job to become available before iterating through the worker loop and repolling the Redis database. Other driver prerequisites. The following dependencies are needed for the listed queue drivers. These dependencies may be installed via the Composer Package Manager. So Amazon SQS, AWS by AWS SDK PHP 3.0, Beanstalk D, PDF by Beanstalk 5.0, Redis, pRedis by pRedis 2.0 or PHP Redis PHP extension. So these are the three minimum driver prerequisites like Amazon SQS, Beanstalk D, Redis. Now we see creating jobs. How do we create jobs? So generating job classes by using job command, make job command we use to generate job classes. PHP artisan make job process forecast. So it will create process forecast job. Class structure. So class process forecast implements should queue. So should queue is a contract interface. This process forecast implements should queue interface. Handle method dependency injection. So the handle method is invoked when the job is processed by the queue. Queued relationships. So to prevent relations from being serialized, we can call without relations method on the model. Unique jobs. Unique jobs require a cache driver that supports locks. So currently, the memcached, Redis, DynamoDB, database, file and array cache drivers support atomic locks. Sometimes we may want to ensure that only one instance of a specific job is on the queue at any point in time. So we may do so by implementing the should be unique interface on our job class. Keeping jobs unique until processing begins. So by default, unique jobs are unlocked after a job completes processing or fails all of its retry attempts. However, there may be situations where we would like our job to unlock immediately before it is processed. So to accomplish this, our job should be unique until processing contract instead of the should be unique contract. So in this way we will be keeping jobs unique until processing begins. Unique job logs. Behind the scenes, when a should be unique job is dispatched, Laravel attempts to acquire a lock with the unique ID key. If the lock is not acquired, the job is not dispatched. We may define a unique fire method that returns a cache driver that should be used. So Laravel will use the default cache driver to obtain when the lock is released, job completes processing or fails all of its retry attempts. Encrypted jobs. Laravel allows us to ensure the privacy and integrity of jobs data via encryption. So to get started, simply add should be encrypted interface to the job class. Job middleware. Job middleware allows us to wrap custom logic around the execution of queued jobs, reducing boilerplate in the jobs themselves. So handle method will be used to leverage Laravel's Redis rate limiting features to allow only one job to process every 5 seconds. Instead of rate limiting in the handle method, we could define a job middleware that handles rate limiting. So Laravel does not have a default location for job middleware. So we can place job middleware anywhere in our applications. In this example, we can place, for example, we can place middleware in an app jobs middleware directory. After creating job middleware, we may be attached to a job by returning them from the jobs middleware method. This method does not exist on jobs scaffolded by the make:"job" command. So we will need to manually add it to our job class. Rate limiting. We will be using rate limiter, facade and limit classes in order to handle the rate limiting. It will be like this: rate limiter, for method, backups, function, object, $job, return $job, user, VIP customer, limit, none, limit per hour, by, job user ID. So like this we will be using the rate limited. Rate limited middleware. Once we have defined our rate limit, we may attach the rate limited to our job using the rate limited middleware. So it will be like this. Within the middleware method, public function middleware array return new rate limited of backups. Releasing a rate limited job back onto the queue will still increment the job's total number of attempts. So we wish to tune our tries and max exceptions properties on our job class accordingly. So we may wish to use the retry until method to define the amount of time until the job should no longer be attempted. If we do not want a job to be retried when it is rate limited, we may use do not release methods. Preventing job overlaps. So Laravel includes them without overlapping middleware that allows us to prevent job overlaps based on an arbitrary key. So this can be helpful when queued job is modifying a resource that should only be modified by one job at a time. Sharing lock keys across job classes. So we will be using shared method. So by default, without overlapping middleware will only prevent overlapping jobs of the same class. So although two different job classes may use the same lock key, so they will not be prevented from overlapping. We can instruct Laravel to apply the key across job classes using the shared method. Throttling exceptions. We will be using throttles exceptions middleware. Dispatching jobs. Once we have written our job class, we may dispatch it using the dispatch method on the job itself. So the arguments passed to the dispatch method will be given to the jobs constructor. Delayed dispatching. So we will be using delay method. So when dispatching the job. So in order to specify that a job should not be immediately available for the processing by a queue worker, so we may use the delay method. The job should not be immediately available for processing by a queue worker, so we may use the delay method. Dispatching after the response is sent to the browser. So the dispatch after response method delays dispatching a job until after the HTTP response is sent to the user's browser if our web server is using fast CGI. So dispatch after response method is used to dispatching after the response is sent to the browser. Dispatch after response. Synchronous dispatching. If you would like to dispatch a job immediately, we may use the dispatch sync method. Jobs and database transactions. Laravel provides several methods of working around. We may use after commit connection option in our queue connections configuration array. When the after commit option is true, we may dispatch jobs within database transactions. Setting the after commit configuration option to true will also cause any queued event listeners, mailables, notifications, and broadcast events to be dispatched after all open database transactions have been committed. After commit. If we do not set the after commit queue connection configuration option to true, we may still indicate that a specific job should be dispatched after all open database transactions have been committed. To accomplish this, we may chain after commit method onto our dispatch operation. After commit method. If the after commit configuration option is set true, we may indicate that a specific job should be dispatched immediately without waiting for any open database transactions to commit. So we will be using before commit. Before commit method. It is not after. So before commit method. Job chaining. Job chaining allows us to specify a list of queued jobs that should be run in sequence after the primary job has been executed successfully. Chain connection and queue. If you would like to specify the connection and queue that should be used for the chain jobs, we may use the on connection and on queue methods. These methods specify the queue connection and queue name that should be used unless the queued job is explicitly assigned to a different connection or queue. Adding jobs to chain. We may need to prepend or append a job to an existing job chain from within another job in that chain. So we may accomplish this using the prepend to chain and append to chain methods. Chain failures. When chaining jobs, we may use catch method to specify a closure that should be invoked if a job within the chain fails. The given callback will receive the throwable instance that caused the job failure. Customizing the queue and connection. Dispatching to a particular queue. By pushing jobs to different queues, we may categorize our queue jobs and even prioritize how many workers you assign to various queues. To specify the queue, we use onQueue method when dispatching the job. This does not push jobs to different queue connections as defined by our queue configuration file, but only to specific queues within a single connection. We will be using onQueue method. We may specify the jobs queue by calling the onQueue method within the jobs constructor. For example, $G is onQueue processing. Dispatching to a particular connection. So if our application interacts with multiple queue connections, we may specify with connection to push a job to using the onConnection method. We may chain the onConnection and onQueue methods together to specify the connection and the queue for a job. Specifying max job attempts or timeout values. So we use the PHP artisan queue work --thrice equal to 3. One approach to specifying the maximum number of times a job may be attempted is via the --thrice method, thrice option. Time-based attempts. So as an alternative to defining how many times a job may be attempted before it fails, we may define a time at which the job should no longer be attempted. So this allows a job to be attempted any number of times within a given time frame. To define the time at which a job should no longer be attempted, add a retry until method to our job class. So this should run a datetime instance. Max exceptions. Sometimes we may wish to specify that a job may be attempted many times, but should fail if the retries are triggered by a given number of unhandled exceptions. So to accomplish this, we may define a max exceptions property on our job class. Timeout. So to specify the maximum number of seconds that jobs can run may be specified using the -timeout switch on the artisan command. So how long we expect our queued jobs to take. Laravel allows us to specify a timeout value. The timeout value is 60 seconds. If a job is processing for longer than the number of seconds specified by the timeout value, the worker processing the job will exit with an error. The maximum number of seconds that the jobs can run may be specified using the timeout timeout switch on the artisan command line. It will be like this: PHP artisan q:work timeout equal to 30. So if the job exceeds its maximum attempts by continuing timeout, it will be marked as failed. Failing on timeout. If you would like to indicate that a job should be marked as failed on timeout, so we may define the fail on timeout property on the job class. So public $fail on timeout equal to true. Error handling. If an exception is thrown while the job is being processed, the job will automatically be released back onto the queue, so it may be attempted again. The job will continue to be released until it has been attempted the maximum number of times allowed by our application. The maximum number of attempts is defined by the tries switch to used on the q:work artisan command. The maximum number of attempts may be defined on the job class itself. Manually releasing a job. Sometimes we may wish to manually release a job back onto the queue so that it can be attempted again at a later time. So we may accomplish this by calling the release method. By default, release method will release job back onto the queue for immediate processing. We may instruct a queue to not make the job available for processing until a given number of seconds has elapsed by passing an integer or date instance to the release method. Manually failing a job. Occasionally we may need to manually mark a job as failed. To do so, we may call the fail method, $this fail method. If you would like to mark our job as failed because of an exception that we have caught, we may pass the exception to the fail method. So it will be like this: $this fail of $exception, or $this fail of something went wrong. So like this we will be passing the exception to the fail method in order to indicate that the job has been failed. Job batching. So we will be using Laravel's job batching feature, which allows us to easily execute a batch of jobs and then perform some action when the batch of jobs has completed executing. So before getting started, we should create a database migration to build a table which will contain meta information about our job batches, such as their completion percentage. So this may be generated using the make column q batches table. So command will be like this: PHP artisan make column q batches table. So PHP artisan migrate. Defining batchable jobs. To define a batchable job, we should create a queuable job as normal. So we should add illuminate bus batchable triad to the job class. Batchable triad to the job class. This triad will provide access to a batch method which may be used to retrieve the current batch that the job is executing within. Dispatching batches. To dispatch a batch of jobs, we should use the batch method of the bus packet. Of course, batching is primarily useful when combined with completion callbacks. We may use the then, catch, and finally methods to define completion callbacks for the batch. So each of these callbacks will receive an illuminate bus batch instance. So when they are invoked, we will imagine for example, we are doing a batch of jobs that each process a given number of rows from a CSV file. So like this we will be dispatching the batch of jobs. Naming batches, we will be using name method. Batch connection and queue, we will be using on connection method and on queue methods in order to batch a connection and queue. chains and batches. So we may define set of chained jobs within a batch by placing the chain jobs within an array. Adding jobs to batches. So we will be using batch method. Sometimes it may be useful to add additional jobs to batch from within a batch job. We will use the load import batch job to hydrate the batch with additional jobs. To accomplish this, we may use add method on the batch instance that may be accessed via the jobs batch method. Inspecting batches. So the illuminate bus batch instance that is provided to batch completion callbacks has a variety of properties and methods to assist you in interacting with and inspecting a given batch of jobs. Returning batches from routes. All illuminate bus batch instances are JSON serializable, so meaning can return them directly from one of our application's routes to retrieve a JSON payload containing information about the batch, including its completion progress. So this makes it convenient to display information about the batch's completion progress in our application's UI. To retrieve a batch by its ID, so we may use the bus packets find batch method. Cancelling batches. Sometimes we may need to cancel a given batch's execution. So this can be accomplished by calling the cancel method on illuminate bus batch instance. We may have noticed in the previously batch jobs should typically determine if the corresponding batch has been cancelled before continuing the execution. For convenience, we may assign skip if batch cancelled middleware to the job instead. So as its name indicates, this middleware will instruct Laravel to not process the job if its corresponding batch has been cancelled. Batch failures. When a batched job fails, the catch callback will be invoked. So this callback is only invoked for the first job that fails within the batch. Allowing failures. When a job within a batch fails, Laravel will automatically mark the batch as cancelled. We may disable this behavior so that a job failure does not automatically mark the batch as cancelled. So this may be accomplished by calling the allow failures method while dispatching the batch. Retrying failed batch jobs. For convenience, Laravel provides queue retry batch artisan command that allows us to easily retry all of the failed jobs for a given batch. The query retry batch command accepts the UUID of the batch. All failed jobs should be retried. So it will be like this: PHP artisan q colon retry hyphen batch in the batch code. Pruning batches. Without pruning, the job underscore batches table can accumulate records very quickly. So to mitigate this, you should schedule the q colon prove batches artisan command to run daily. By default, all finished jobs that are more than 24 hours old will be pruned. We may use the hours option when calling the command to determine how long to retain batch data. Schedule command q prune batches hours equal to 40 hours daily. So sometimes our jobs underscore batch table may accumulate batch records for batches that never completed successfully, such as batches where a job failed and that job was never retried successfully. So we may instruct a q colon prune batches command to prune these unfinished batch records using the unfinished option. So syntax will be like this: schedule command, within that command q colon prune batches hyphen hyphen hours equal to 48 hyphen hyphen unfinished equal to 72 daily method. So like this we will be using the syntax. Storing batches in DynamoDB. Laravel also provides support for storing batch meta information in DynamoDB instead of the relational database. However, we will need to manually create a DynamoDB table to store all of the batch records. So we will be using DynamoDB configuration command in order to create a DynamoDB batch table. So we will be using composer. This is to create AWS SDK, like composer require AWS SDK PHP. Pruning batches in DynamoDB. When utilizing DynamoDB to store job batch information, the typical pruning commands used to prune batches stored in relational database will not work. So instead, we may utilize DynamoDB's native TTL functionality to automatically remove records for old batches. Queuing closures. Instead of dispatching a job class to the queue, we may also dispatch a closure. So this is great for quick, simple tasks that to be executed outside of the current request cycle. So when dispatching closures to the queue, the closure's code content is cryptographically signed so that it cannot be modified in transit. So using the catch method, we may provide a closure that should be executed if the queued closure fails to complete successfully after exhausting all of our queue's configured retry attempts. Since the catch callbacks are serialized and executed at a later time by the Laravel queue, so we should not use the $this variable within catch callbacks. Running the queue worker, the q work command. So Laravel uses q work command, which will continue to run until it's manually stopped or close to our terminal. Laravel includes an artisan command that will start a queue worker and process new jobs as they are pushed onto the queue. So the command will be like this: php artisan q work. To keep the q work process running permanently in the background, so we should use process monitor such as supervisor to ensure that the queue worker does not stop running. php artisan q work -v. We may run the q listen command when using q listen command, so we don't have to manually restart the worker when you want to reload our updated code or reset the application state. So this command is significantly less efficient than the q work command. php artisan q listen. Running multiple queue workers. To assign multiple workers to a queue and process jobs concurrently, we should simply start multiple q work processes. This can either be done locally via multiple tabs in our terminal or in production using our process manager's configuration settings. We may use the numprox configuration value. Specifying the connection and queue. We may also specify which queue connection the worker should utilize. The connection name passed to the work command should correspond to one of the connections defined in our config/q.php configuration file. It will be like this command: php artisan q work redis. So like this we will be specifying the connection and queue. If all of our emails are processed in an emails queue, on our Redis queue connections, we may issue command like this: php artisan q:work redis --q equal to emails. Processing a specified number of jobs. The -once option may be used to instruct the worker to only process a single job from the queue. PHP artisan q:work -once. The -max jobs option may be used to instruct the worker to process the given number of jobs and then exit. So this option may be useful when combined with supervisor so that our workers are automatically restarted after processing given number of jobs, releasing any memory they may have accumulated. So command will be like this: php artisan q:work -max -jobs equal to 1000. Processing all queued jobs and then exiting. php artisan q:work -stop -when -empty. Processing jobs for a given number of seconds. php artisan q:work -max -time equal to 3600. Worker sleep duration. So when jobs are available on the queue, the worker will keep processing jobs with no delay in between jobs. So php artisan q:work -sleep equal to 3. Maintenance mode and queues. While our application is in maintenance mode, no queued jobs will be handled. So the jobs will continue to be handled as normal once the application is out of maintenance mode. So to force our queue workers to process jobs, even if maintenance mode is enabled, we may use -force option. So php artisan q:work -force. Like this, we can enable maintenance mode and queues. Resource considerations. Daemon queue workers do not reboot the framework before processing each job. So therefore, we should release any heavy resources after each job completes. Queue priorities. So we will be using onQueue method in order to mention priority, like onQueue high. So dispatch new job onQueue high, like this. So to start a worker that verifies that all of the high queue jobs are processed before continuing any jobs on the low queue, pass a comma delimited list of queue names to the work command. So it will be like this: php artisan q:work -q equal to high comma low. So like this we will be mentioning the priority. Queue workers and deployment. Since queue workers are long-lived process, they will not notice changes to our code without being restarted. So the simplest way to deploy an application using queue workers is to restart the workers during our deployment process. So command will be like this: php artisan q:restart. Job expirations and timeouts. So in our config or queue.php configuration file, each queue connection defines retry _after option. So this option specifies how many seconds the queue connection should wait before retrying a job that is being processed. Worker timeouts. So the q:work artisan command exposes --timeout option. So by default, the --timeout value is 60 seconds. If a job is processing for longer than the number of seconds specified by the timeout value, the worker processing the job will exit with an error. So typically the worker will be restarted automatically by a process manager configured on our server. So command will be like this: php artisan q:work -timeout equal to 60. So like this we will be mentioning the worker timeouts. Supervisor configuration. So In production, we may want to keep our queue colon work process running. A queue colon work process may stop running a variety of reasons, such as exceeded worker timeout or the execution of the queue restart command. So for this reason, we may want to configure a process monitor that can detect when our queue colon work process exit and automatically restart them. So in addition, process monitors can allow us to specify how many queue colon work processes we would like to run concurrently. Supervisor is a process monitor commonly used in Linux environments, and we will discuss how to configure it in the following commands like this: sudo apt-get apt-get install supervisor, sudo apt-get install supervisor. So it will be, the command will be like this. So configuring supervisor, laravel-worker.conf, C configuration file, conf configuration file. So in this we will be configuring the supervisor, like a process name, command, auto start, auto restart, stops group, stop as group, kill as group, user, numprax, redirect underscore std error, std out log file, std stop wait specs, stop wait 6 seconds. So like this we will be using the configuration file in order to configure supervisor in a Linux environment. Starting supervisor. So once the configuration file has been created, we may update the supervisor configuration and start processes using the following commands: sudo supervisor ctl reread, sudo supervisor ctl update, sudo supervisor ctl start laravel worker :star. So like this we are using the supervisor commands. Dealing with failed jobs. So we will be using artisan commands like this: php artisan make queue failed table, so which will contain all the failed jobs. After that we will be running the command php artisan migrate. So when running a queue worker process, we may specify the maximum number of times it should attempted using the -tries equal to -tries option. So we will be using the command like this: php artisan queue work reduce -tries equal to 3. And also backoff option, backoff option, we may specify how many seconds Laravel should wait before trying a job that has been encountered an exception. So by default a job is immediately released back onto the queue so that it may be attempted again. So php artisan queue work reduce -tries equal to 3, backoff equal to 3. Like this we will be using the backoff option. Cleaning up after failed jobs. When a particular job fails, we may want to send an alert to our users or revert any actions that were particularly completed by the job. So to accomplish this, we may define a failed method on our job class. So the throwable instance that caused the job to fail will be passed to the failed method. Retrying failed jobs. So we will be having a command like this. To view all of the failed jobs that have been inserted into our failed jobs database table, we may use command like this: php artisan queue failed. This is the artisan command in order to view all the failed jobs in the database table. And also we are having artisan commands like this: php artisan queue retry, and the code, the ID of failed jobs. And also you will be passing multiple IDs to the queue retry command: php artisan queue retry IDs, different IDs of failed jobs. And we may also retry all of the failed jobs for a particular queue, like php artisan queue retry q is equal to name. So to retry all of our failed jobs, execute the q colon retry command and pass all as the id. So php artisan q colon retry all. So like this we will be using the all command, retry all command in order to retry all of our failed jobs. So if you would like to delete a failed job, we may use the q colon forget command. So php artisan q colon forget the id of failed job. So like this we will be using the forget command. To delete all of our failed jobs from the failed jobs table, we may use q flush. So php artisan q colon flush command is used. Ignoring missing models. So when injecting an eloquent model into a job, so the model is automatically serialized before being placed on the queue and retrieved from the database when the job is processed. If the model has been deleted while the job was waiting to be processed by a worker, so our job may fail with a model not found exception. So we will be using option delete when missing models property to true. Like this we will be ignoring missing models. Public $delete when missing models equal to true. Pruning failed jobs. We may prune the records in our application's failed jobs tables by invoking q colon prune hyphen failed. So command will be like this: php artisan q colon prune hyphen failed. By default, all the failed job records that are more than 24 hours old will be pruned. So if you provide the hyphen hours option to the command, only the failed job records that were inserted within the last n number of hours will be retained. For example, the following command will delete all the failed job records that were inserted more than 48 hours ago. So like this, php artisan q colon prune hyphen failed hyphen hours equal to 48. Now we see the concept of storing failed jobs in DynamoDB. Laravel also provides support for storing our failed job records in DynamoDB instead of a relational database table. So we must manually create a DynamoDB table to store all of the failed job records. So typically this table should be named failed underscore jobs, but should name the table based on the value of the q.failed.table configuration file within our application's q configuration file. Option will be q.failed.table. The failed jobs table should have a string primary partition key named application and a string primary sort key named UUID. The application portion of the key will contain our application's name as defined by name configuration value within our application's app configuration file. So the command will be like this in order to create AWS SDK. So pcomposer require AWS by AWS SDK -php. AWS SDK -php. Disabling failed job storage. We may instruct Laravel to discard failed jobs without storing them by setting the q.fail.driver configuration options value to null. So typically this may be accomplished via the q_failed_driver environment variable. So q_failed_driver equal to null. Like this we will be using the configuration option. Failed job events. If you would like to register an event listener that will be invoked when a job fails, we may use the qFackets_failing method. So we may attach a closure to this event from the boot method of the app service provider that is included with Laravel. Creating jobs from queues. So if we would like to delete all jobs from the default queue of the default connection, we may do so using the q::clear artisan command. So php artisan q::clear. We may also provide the connection argument and queue option to delete jobs from a specific connection and queue. PHP artisan queue colon clear redis hyphen queue is equal to emails. Monitoring our queues. Use the command called PHP artisan queue colon monitor redis colon default redis colon deployments hyphen max is equal to 100. We should schedule the queue colon monitor command to run every minute. So the command accepts the name of the queues like this we wish to monitor as well as our desired job count threshold. So here hyphen max is equal to 100. This is a count threshold. Scheduling this command alone is not enough to trigger a notification alerting us of the queue's overwhelmed status. So when the command encounters a queue that has a job count exceeding our threshold, an illuminate queue events queue busy event will be dispatched. So we may listen for this event within our application's app service provider in order to send a notification to our development team. Testing. When testing code that dispatches jobs, we may wish to instruct Laravel to not actually execute the job itself. So since the job's code can be tested directly and separately of the code that dispatches it. To test the job itself, we may instantiate a job instance and invoke the handle method directly in our test. The assertions are different assertions are there. They are like this: assertion nothing pushed, assertion pushed on, assert pushed, assert not pushed, assert closure pushed, assert count. Now we see faking a subset of jobs. So we will be using fake method. Q double colon fake ship order double colon class. So like this we will be using the fake method. Testing job chains. And previously you see subset means like except method also can also used in order to specify, in order to fake specific jobs, set of specified jobs. Now we see testing job chains. To test job chains, we will need to utilize bus packets faking capabilities. So the bus packets assert chained method may be used to assert that a chain of jobs was dispatched. The assert chain method accepts an array of chained jobs as its first argument. So like this we will be testing job chains. Testing chain modifications. If a chained job prepends or appends jobs to an existing chain, so we may use the jobs assert has chain method to assert that the job has an expected chain of remaining jobs. The assert does not have chain method may be used to assert that the job's remaining chain is empty. Testing chained batches. If our job chain contains a batch of jobs, we may assert that chained batch matches our expectations by inserting a bus double colon chain batch definition within our chain assertion. Testing job batches. The bus packets assert batch method may be used to assert that a batch of jobs was dispatched. So like this we are having different assertions. Testing job or queue interactions. We may use assert released, assert deleted, assert not deleted, assert failed, and assert not failed methods may be used to make assertions against jobs queue interactions. Job testing job batch iteration. So we will be using with fake batch method in order to test job or batch interaction. Job events. Using the before and after methods on the queue, queue facade. So we may specify callbacks to be executed before or after a queued job is processed. These callbacks are a great opportunity to perform additional logging or increment statistics for a dashboard. Typically, we should call these methods from the boot method of a service provider. So we may use the app service provider that is included with Laravel. So before method, after method, like this we'll be using queue facade methods. So this is all about queues concept in Laravel. Thank you so much. Thanks to all of my fans, supporters and followers. Special thanks to all of my YouTube subscribers. This is Universal Heart Sister Ravindar Reddy Yampalla. Thank you so much.